Hey everyone, welcome to Chem. We're going to look at a solubility curve and do a little bit of practice on how to read it and how to figure out what substances have a certain solubility per 100 grams of water at a specific temperature. So on the left here, this is an example of what a solubility curve would look like. Across the x-axis on the bottom, you see temperature in degrees Celsius from 0 to 100. And up the y-axis on the side, you see 0 to 100. And it's telling you that it's the solubility, which is grams of salt in 100 grams of water. So the substances you see on that chart will dissolve inside the water at a specific temperature. So if you look, for most of them, as the temperature is increasing, the lines have an upward trend, which means that, as you increase the temperature of the water, as it gets warmer, more solids are going to dissolve. And that should make sense, right? Because the solubility of a solid increases as the temperature increases. That's not always the case, but it's, usually the case for most substances. Over to the right here, it says write the name of each formula. I am not going to do all of them for you because this should be 100% review. I'll do some, sure, the sketchy looking ones, but most of them you should be able to do yourself. So first one should be okay. The second one should be okay. The third one might be kind of sketchy. The PbNO3 well, Pb is lead and NO3 is nitrate, and it's lead 2 nitrate because of that little subscript after the NO3. So lead 2 nitrate. Next one should be okay. KClO3. Lots of students will want to say potassium, chlorine, oxygen. Well, no. The ClO3, that's a polyatomic ion. So that is potassium chlorate. The ClO3 is chlorate. And then this last one here could also be maybe sketchy. The Ce is cesium and the SO4 is sulfate. So cesium sulfate. The rest should be okay. Keep in mind that it's Cl. So for example, the second one down there is CaCl2. Some students make the mistake of saying carbon iodine. It's not. Okay, don't let that Arial font goof you up. Just like this one too. So this one is CaCl2, NaCl, and then KCl. Okay, don't say carbon iodine. That would be wrong. Just as a little hint. So let's take a look at the solubility curve here, this chart. So like I was saying, as the temperature of the water increases, the solubility of the solid inside that solution is going to go up. So all you're doing really is checking out the temperature that they're asking you about, tracing your finger up the gray line till you hit the colorful line, and then trailing your line or your finger over to the y-axis to figure out how much dissolves. So let's look at that first question together here. It says, what is the solubility of KCl, potassium chloride, at 40 degrees Celsius? Well, they said 40 degrees Celsius, so that's the first place I'm going to look. 40 degrees Celsius is right here, and they're asking me about potassium chloride. So I am going to trace my highlighter up to that blue line, the KCl line, and then it wants to know, okay, well, how much of that substance is going to dissolve? Well, all I have to do is take my finger. I'm actually going to switch to a pen here so it doesn't goof us up. So 40 degrees Celsius is this much. I hit that line about here, which if you notice is slightly below 40. So if I were to give an educated guess, I would say that about 39 grams of that substance I would say about 39 grams of the potassium chloride will dissolve per 100 grams of water. Should have been easy peasy, I hope. Well, I'm going to skip number 2. And the reason why is because if you can do number 1, you could do number 2. But instead of doing number 2, I'll just pick another random example. So, what is the solubility of potassium nitrate? This guy. What is the solubility of potassium nitrate at 20 degrees Celsius? Well, same process. Trail your finger up to the green line and then trail your finger over to the left. This one was an easy one. It kind of intersected at a nice spot. So for potassium nitrate, okay, the solubility, so I'll just put my made up example over here. So for KNO3, okay, at, let's say 20 degrees Celsius, we are going to say that 30 grams of KNO3 will dissolve per 100 grams of water. Okay, so those 2 little examples should help you with number 2, because I'm going to leave that so you can get some points for that. Number 3, it says, calculate the mass of sodium chloride needed to make a saturated solution in 175 grams of water at 90 degrees Celsius. Okay, well, there's a couple things here. Number 1, we need to remember what saturated and unsaturated are. So remember, okay, an unsaturated solution, okay, I'll just put these quick little notes off to the side here. So an unsaturated solution, okay, that solution will continue to take in solute, okay? Okay, so there are no solid particles at the bottom of a glass, we'll say, so at the bottom. Okay, and the solute will dissolve. So that's like you're adding Kool-Aid, adding Kool-Aid, adding Kool-Aid, and stirring, and you're not seeing any solid particles at the bottom. Once you are saturated, though, things change. Okay, there's solid at the bottom. Okay, the solution cannot take any more. Okay, you've reached that maximum level of where the solid dissolves. Okay, and then that's where you get that recrystallization, and that's why you have solid at the bottom. Okay, so going back to number 3 here, it says calculate the mass of the sodium chloride needed to make a saturated solution in 175 grams of water at 90 degrees Celsius. Okay, well, they asked us a lot of stuff here, but they did give us some information. So they said we're looking at sodium chloride, NaCl. So this is the line we have to pay attention to. And they're asking us what's going on at 90 degrees Celsius. So we do know that at 90 degrees Celsius, okay, you are going to have 40 grams of that solute. Okay, that's the saturation level. So that's what you know. So at 90 degrees Celsius, 40 grams of the NaCl can dissolve in 100 grams of water. That's the saturation point. But they're not asking us about 100 grams. They're asking us about 175 grams. Well, this is kind of like a proportion. So what you have to do is set it so what you don't know is over what you need to know. Okay, so you know that at 90 degrees Celsius, 40 grams of NaCl will dissolve in 100 grams of water. But they're asking you, okay, what if you have a little bit more water? How much could you get in there? Well, we don't know that. Easiest way to solve this problem, one of my favorite things to do, cross multiply. Okay, so cross multiply these two numbers, cross multiply these two numbers. There's not a lot of room, so I'm going to scoot over to the right there. 100 grams of water times X, I'll put that on my left side. So 100 grams times X, which is what I'm trying to find, so I'm going to highlight it. Okay, and I'm going to set that equal to 40, and you multiply that by 175, which will get you 7,000, and I got to keep my units, grams of water times grams NaCl. At this point, this should look quite familiar. How do you get X by itself? You have to divide each side by 100 grams of water. Divide each side by 100 grams of water. Okay, this is going to cancel here. And you're going to be left with X equaling, you solve it. I'm not giving you the answer. That's going to get you the points. Okay. Number 4. If a saturated solution of potassium nitrate in 100 grams of water is cooled from 50 to 30 degrees Celsius, what mass of solute will crystallize out? Okay, well, they're asking us what's the solubility of potassium nitrate, KNO3, at 50 degrees Celsius, and then what's it at 30? It's simple subtraction. All right, so let's erase this. They're asking me about this guy right here. So they want to know at 50 degrees Celsius and then 30 degrees Celsius. Well, if I trail my finger up for the 50, that's going to be about here-ish. And then let me use a different color for 30. 30, go up to that green line here, looking at about here. So it's at 50 degrees Celsius, we could say that it's, you did a very good job here. Say it's about 88 grams at 50 degrees Celsius, 88, 89-ish. And then at 30 grams, we could say that's about, 44, 45-ish. You're eyeballing it, so I'm not going to be too much of a stickler about that. So at 50 degrees Celsius, we're going to say about 89 or 88 grams of KNO3. Okay, is the solute. And then at about 30 degrees Celsius, I'm going to say maybe 45 grams KNO3. So I want to know what's going to crystallize out. I'm not solving it. You solve it, you tell me. Number 5. If you added 10 grams of potassium chlorate at 60 degrees, what type of solution would you have? So you have to look at 60 degrees at potassium chlorate. Okay, so let me erase all this stuff. So potassium chlorate right here at 60 degrees. And it's saying if you only added in 10 grams, what type of solution would you have? Well, if you are underneath the line, not touching it at all, below the line means, for any of these lines, unsaturated. Above the line, at the line and above, means saturated, and that's really important. So I'm going to write that down here in red. Below the line equals unsaturated. That means solute's going to dissolve. At the line and above is a saturated solution. No more will dissolve, you will have solids. Okay? So that being said, you should be able to tell me the answer to number 5, and I might have already said it. Number 6, which solutions would be saturated? Okay, so look at what I just wrote in red. Above 50 degrees Celsius with 50 grams of solute per 100 grams of water. So you're looking at above 50. So what I would do is take my highlighter above 50. So basically from here all this way. Okay, so it's that portion of the chart, but then it's asking 50 grams of solute. Okay, so 50 grams of solute. So that would be this much right here. So 50 grams of solute. What it's asking you is which of these would be saturated. So at above 50 degrees, so 50, 60, 70, 80, 90, all the way up to 100, and then 50 grams of solute, which would be saturated. Okay? So if you remember what we wrote, at the line and above means saturated. So only a few lines are in that zone, and only a few lines are going to be considered saturated. So I'm not going to answer that. I'm going to need you to write down the couple that are going to be saturated above 50 degrees Celsius. But I kind of narrowed it down for you there, because above the line means saturated. So if you've got 50 grams and your line is below it, that should tell you something. Email me if you have questions.